Number 4 was coming from analysis, but specifically integration. So let us see how we handle number 4. Now we see that to handle number 4, we are supposed to first resolve that partial fractions properly so that we can easily integrate that function. So number 4. So that we had 1 over 9. First resolve it into the partial fractions. You see this one is a difference of 2 squares. So my a into equals to 1. So when x is the 3, this will go. B having 3 plus 3 is 6 equals to 1. So my b will be 1 over 6. And then when x is negative 3, put here negative 3, b having 6a, this will go equal to this. So your a will be 1 over 6. So now our integral, which was from 0 to 1, is now the integral from 0 to 1 of our a, which is 1 over 6, 3 plus x, dx, to 1 over 6, the b, over 3 minus x, dx. So it's 1 over 6 is common, so you can factor it out. But now you integrate this, you get natural log, then minus. You see this one, we are having minus because when you shade this, you get a minus. So natural log of 3 minus x, then we put in our limits from 0 to 1. So if I substitute in the limits now, there, when I put in now the upper limit, be having now natural log, this will be when I put in 1, I have 4, minus, put in 0 there, you'll be having 4 minus 1, you have natural log of 2, that is now the upper limit, minus, we substitute in the lower limit. Here, when I put in 1, when I put in 0, I'll be having natural log of 3, minus, when I put in 0 there, have still natural log of 3. See this one, we'll go with this. So I have this, which would be 1 over 6, natural log of 4 divided by 2. Remember, when subtracting 2, we divide these 2, which will be 1 over 6, natural log of 2. And that's what they wanted us to show. When I come to number 2, it was coming from algebra, specifically series of GP. So, number 5, you know, they are telling us that the population is increasing in a GP at a rate of 2.75% per annum. So you know that our AN is P into 1 plus R power N. Now my R here is 2.75%, which is 0.0275. So telling me that the initial, of course, the initial population is going to be P naught. So if the initial population is P naught. So meaning, in simple terms, this is going to act as our P there. So now they want the number of years when this population doubles. So our AN now is going to be 2P naught. When I substitute here, I have equals the initial population into 1 plus power N. Clearly, my P goes. So getting me 2 equals to 1.0275, the whole power N. Here we just introduce natural log to simplify. Introduce natural log, the N will lower there, 1.0275. So it's that my N is going to be to my n, and here my n will be will be 25.55 to decimal places equal to n, which I can approximate to my n approximates to 26 years. Okay, from there we move to number 6, which was coming from trig. They want us to prove something there. So we start from the left hand side. So number 6, clearly you can see. Now my left hand side is going to be equaling to squared x over 1 plus cos to x. Okay, now we can see 1 minus cos to x from our identities from the double angle of the cos is always equaling to 2 sine squared x plus this over, when you have a positive 1 plus cos 2x, get 2 cos squared x. Our next step is now to, you see that on our right hand side they have 1 down, so I'm going to divide it through by this here, here and there. So this will be now 2 cos squared x. So my 2 there. So this will go. This will give you tan squared x. This 2 will go. The cos will go to give you plus sine x. And down you're going to be having the 1. When we rearrange, it's going to give us equals to the right hand side. So we have shown that left hand side is equal to the right hand side. So basically those are the numbers, solutions for 4, 5 and 6. But if you want to see how we come from this step, please go to the playlist and then visit the trig part. You will see all these ones, how we get this from this and how we get this to this. Anyway, that's it. And that's the last 2.